XSPICE is a control and data acquisition device that can be used for performing a variety of science experiments. In order to use it, one needs to understand the input-output connectors of XSPICE. Here, the waveform generator is capable of generating a sine or triangular wave, and its frequency can be varied from 1 Hz to 5 kHz. The peak voltage of WG can be set to 3 volt, 1 volt or 80 millivolts. WG bar is an inverted output of WG. OD1 is a digital output that can be set to 5 volt or 0 volt under software control. Square 1 and Square 2, marked as SQ1 and SQ2, are square wave generators. Their frequency can be varied from 1 Hz to 5 kHz, and the amplitude changes from 0 to 5 volts. PV1 and PV2 are programmable voltage sources, and the voltage output of PV1 can be set anywhere from -5 volt to +5 volts under software control, and for PV2 the range is -3.3 to +3.3. CCS is a constant current source that will give a current of 1.1 milliampere to a load less than 2 kilo ohms. Those are the connectors on the output block, and all the terminals marked in the black color, they are ground terminals. And the input block, you have in1 that is used for measuring capacitance. You can connect a small capacitor between ground and in1, and the device will measure the capacitance. In2 is for measuring frequency of pulse inputs. For example, the square 2 or square 1 output you can connect to in2, and one can measure the frequency and duty cycle of the pulse. The SEN is the sensor inputs that is generally used for connecting phototransistors and other sensors. Their resistance change proportional to some other physical parameter. A1, A2 and A3 are terminals for measuring voltage. A1 and A2 can handle an input ranging from -16 volts to +16 volts, and it is capable of making 1 million measurements per second. That means a sampling rate of 1 megasamples per second. And A3 has an input range of -3.3 volts to +3.3 volts, and the signal given to A3 can be amplified by connecting a resistor RG, and the amplification factor is given by 1 plus 10,000 by RG. For example, if you connect a 1 kilo ohm resistance, 1 plus 10,000 by 1000, that is 1 plus 10, the gain will be 11. We also have a mic terminal where you can connect a condenser mic, and the output of the microphone will be captured by the device. In addition to these two blocks, we have a small connector here. There you have a -V and a +V, that is -6 volts and a +6 volts, that can be used for powering operational amplifiers in some experiments. Then we have a I2C interface where the +5 volt ground, there SCL and SDA. You can interface commercially available sensor elements compatible with the I2C standard.